I've opened up Logger Pro and now I'm going to insert a movie. So I'll just click on insert and it comes down to movie. I'm going to browse for my movie. Mine's actually on the desktop. So I'll just go there. And it's a lovely movie of Mr. Guzay and Ebony. Depending on how long you film for, it might take a little while to import into Logger Pro. Feel free to stop, mate. You're getting out of it.
It's a 4K, high quality family, really.
So it's not too big. Oh, it's not you. Okay. So we just can play the movie to make sure it's the movie we want. Yep, that looks like a pendulum. Okay. So now what I'm going to do is I'm going to come over here and pick the analysis button. If you hover over it, it will come up and say open analysis. So if I click up there, the sidebar opens up along here. Okay, the first thing that you should do, if you've got an option and you know how, if you set this up with a ruler in the screen, okay, you can actually set a scale for the video. So we know Mrs. Guzay, okay, we know her height, okay, it defaults to 1 meter tall, but we know that's not exactly right. She's actually 1.68 meters tall, okay. So, and because that's in the same plane as the motion, okay, that's going to be reasonable. If the ruler was closer to you than the pendulum, it's going to appear bigger than a meter on the actual motion. So you want it to be in the same plane. Now that we know the motion, we want to actually start plotting some points. Okay, so you're going to pick a point on the pendulum. We're going to start plotting points. Okay. And I'm just going to click over this button, the red dot here, which is the add a point button. Okay, and I've got to find a center of mass of my pendulum. Okay, so we're just going to go the center of the seat there, and when I click it, it automatically advances 1 frame.
What's the time for 1 frame?
It automatically works that out too. So we might see some problems with this data because it may not be true pendulum or simple harmonic motion, because we're maybe getting a push every now and then.
But for the swing, it should just be fine, as in the actual one.
Okay, we're guessing here, but it doesn't matter. 1 point out of all this data, the computer's going to put us a line of best fit anyway. You can see in the background on the graph, it's actually starting to plot the X and Y displacement
And
of Evie
what else?
versus time.
It does the vertical and horizontal separately.
Okay.
So when you want to do this, you want to do like 1 full cycle back to where we started.
And that's it.
Then we've just got to get the formulas after that.
Cool.
So that takes a bit of time. The more accurate you get that, the better your graph will look.
Could they technically click on their previous points?
Yeah,
Follow back down perfectly.
technically. Shh, don't listen to this. Imagine they'll be a bit closer than this, though.
Yeah. So strictly speaking, they should have ended up in the same spot.
Yeah.
But it's experimental data.
Yeah.
So we're not expecting it to be perfect. Okay, it's just starting to go over there. Cool. So we can just put that to the background and we're just going to have a look at this graph here. Okay, all of this data is collected in a table, and that on the table, if I show you, it shows y displacement. If I go right back to the start, it goes time, x displacement, y displacement, so it breaks it up into components, okay, and then y velocity and x velocity. Okay, so on the graph, the red dots are x displacement, so the movement from side to side versus time, and the blue is the height change versus time. Okay, you could add all those up to get a two-dimensional picture, but we don't need to do that. We're just going to analyze the sine curve. So you can decide, I think, depending on your assignment, what it stipulates in your assignment, whether you pick the red graph or the blue graph.
No, it doesn't.
And this way you'll get another variable between your data and other people in the classroom.
So can I turn one off?
We're only going to look at vertical data, okay, so the Y data. If I right click over the labels, okay, I get the option of graph options. I'm going to select that, and then it'll open up this box, and then I'm going to select axes options. Okay, at this stage I can pick my y-axis on the graph, so I'm just going to switch off the x-axis, x displacement. While we're here, we're going to look at y velocity graph later on, but I'll just leave that off at the moment. We can always turn it on later, okay, and that'll just give us, it'll rescale the y-axis so that we get a nice full page picture. I'm going to come up here to this button here, okay. When you hover over it, just check that it's saying curve fit, okay, because it's obviously not a straight line, it's not a linear fit. We're going to select curve fit. If I click on there, it opens up a few things. Obviously this isn't a quadratic graph, okay. I'm going to actually have to scroll down until I find the sort of graph that it is, okay, and I'm going to pick the sine curve, okay. Even though it's starting high and maybe a cosine graph might be more appropriate, okay, I don't necessarily, there you go, there is a cosine option down there, okay, but I'm just going to pick sine graph. You can make that decision.
They can choose the one if they start at the top or the bottom of their motion. That's right, choose the one that fits best.
Okay, and then I'm going to click try fit. So I'm going to ask the computer to calculate what it thinks
Tashi Baston to the office.
is the best line of fit. So when I click on that, I think it did. Yeah,
Put all the values there.
Okay, and if I click OK, then it'll give me a close approximation of the graph. Okay, and it'll give me my y equals my formula, and then the values for A, for B, for C, and for D, with an error range there. Okay, we haven't got a bad correlation coefficient there either. Okay, so it's not bad data. Okay, so that's for our displacement versus time graph. Okay, now I'm going to right click on my y-axis again, go to graph options, go to axes options, which is already selected, and this time I'm going to get the velocity versus time graph, and I'll just overlap that over my displacement versus time graph. So I'll see both graphs at the same time. Okay, so it's rescaled it, and the one that's already got the formula attached to it, that's my displacement versus time graph. That's the one with the dots. Okay, I can just move that out of the way. The diamonds down here is my new graph of velocity versus time. Okay, so just like I did before, it's looking pretty much like a sine curve again. So I'm going to ask the computer to calculate the line of best fit by going back to the curve.
Well, if we do sine up there, would we want to move to cos for our comparison when we differentiate it manually?
Okay, so I'm going to select curve fit, but this time I'm not going to do y, I'm going to do y velocity in my analysis. Okay, just make sure you click that one so it knows which graph it wants you want it to analyze. Okay, and it opens up this on again. Okay, it's automatically gone for that. Let's go for the cosine
Ariana Crippen and
function,
Someone's
and
on
we'll
left.
try
Please go to the drama room
to
now.
find the fit. Okay, and you can see it's filling in values there. It actually looks quite nice approximation of our data as well. You can see, you know, I might have made a few errors in where I put those dots, but because I've got so much data, you know, it kind of makes my data better than what I've actually put in. Okay, so there's my line. You can see maybe the amplitude isn't quite getting down to where my data suggests at the bottom and at the top, but that's my line of best fit that the computer has calculated, and that's one of the equations that you're going to use in your assignment. Okay, this